Today we are talking about the derivatives of exponential functions. So far this semester we have learned the derivatives of polynomial functions, rational functions, radical functions, trig functions. I think that pretty much covers it all. But now we're going to go into exponential functions. And so what we're talking about here are functions that have an x in the exponent. We've had functions with exponents before, but they've always been like x to the 2 or x to the 1/2 or x to the -5. We've never had x's in the exponent, and we've got to learn how to take the derivative of those functions. We're going to focus on one specific function today because its derivative is special. Tomorrow we will focus on its cousins and what their derivatives will be. Okay? Today's function is e to the x. Y equals e to the x. You were introduced to e in Algebra 2 and may have been thinking, well, what's so special about this number? You're about to see one of the main things that's very special about this number in just a second. Now, let's take a look at what this graph looks like. E to the x looks just like 2 to the x and 5 to the x, pretty much, except for the steepness of the graph. All exponential functions go through the same point, and it's not 0, 0. Does anybody know what it is? Not 1, 0. 0, 1. They all go through 0, 1. You did a little unit on this in pre-cal last year, both regular and pre-AP. On the left side, the exponential goes down towards 0 but never gets there because it is an asymptote over here. On the right side, it shoots up into the sky very, very quickly. That's why they call it exponential growth. Okay, I am going to demonstrate one thing on the calculator here in just a second. And I didn't want everybody to get out their calculators because this is just very short. So let me show this to you. Okay, I'm going to put e to the x in the calculator, graph it on Zoom 4, and it looks like the sketch that we made. Okay, now just like we did with sine and cosine, I'm going to graph the derivative in y2. And you should be able to tell from the graph what its derivative is going to be. So let's go back to y equals. I'm going to put math 8 d dx of e to the x for all x's. So x equals x. Okay? So now, e to the x is already on the page. Watch what happens when I push graph this time. You ever seen the little circle before?
That's so cool. Can you do that again?
Yes, I can do that again. Oops, wait a minute. Give me a minute. Went too far. Here it goes. There's e to the x, and there's the derivative of e to the x. Why does it do that? I put the little circle on because of the fact that they were so close to each other. Now, do you think they might be the same graph?
Yes.
Maybe. Let's look at the table. That table will tell us for sure. y1 is the original equation. y2 is the derivative. What do you notice? They are the same y values, aren't they? So that tells you that the derivative of e to the x is what? E to the x. Okay? This is the only function whose derivative is itself. Okay? So, I want you to write on your paper right here the derivative of e to the x is e to the x. Very important thing to know. Okay?
No matter how many times you take the derivative, it's always going to be e to the x.
That's exactly right. The other thing that it represents graphically is this, okay? Remember the derivative means slope of a tangent line, right? Okay. So since the derivative, the slope, is equal to the y value, so no matter what point you choose, the slope of the tangent line will always be the same as the y value at that point. So the slope of the tangent line right here is 1 because the y value is 1. If I go up here to where the y value is 3, the slope of the tangent line will be 3. If I go down here to the y value of a half, the slope of the tangent line will be a half because the derivative and the function are the same. Okay? So let's write it in mathematical terms right here. D over dx of e to the x equals e to the x. That's the mathematical way to write down that the derivative of e to the x is e to the x. But it can't always be that easy. You're going to have e to the 2x, or e to the x squared plus 3, or e to the cosine of x. What do you do if it's something different up there? That would be a situation of e to the u, when the power is something other than an x. Well, what you do is chain rule again. Now, I like to refer to this action, write it down again as copy paste, like when you do a Control-C and a Control-V on your computer, right? So the derivative of e to the u, you just copy and paste the e to the u, but then you have to take the derivative of the exponent. So times du over dx. Du over dx, yes. So when you're taking the derivative of e to the power, you copy and paste the function, but then you take the derivative of the power. That's the process for taking the derivative of an exponential. So we're going to practice on this for a little while. Y equals e to the 5x power. Okay? So y prime will be, you copy and paste e to the 5x right there, but then you take the derivative of the exponent, which would be what? What's the derivative of the exponent? Just 5. And then the 5 moves to the front, and you write 5e to the 5x, and that's the answer. Any questions on that one? Okay, the next one. Y equals e to the x squared minus 3x minus 1. That whole thing is the exponent. To take the derivative, y prime, copy and paste e to the x squared minus 3x minus 1. Then you multiply by the derivative of the exponent, which would be what? It's 2x minus 3. Now, some books will stop and leave the answer like that. Some books will take and move the 2x minus 3 to the front. E to the x squared minus 3x minus 1. So either way, in the back or in the front. Any questions? Okay. Your turn to try one. Y equals e to the sine of x power. I want you to try that. I want to come around and check them. When you think you've got it, I want to see it. Y prime equals copy paste e to the sine of x times cosine of x. And you can move the cosine to the front, like so. Okay. Any questions on that problem? That was easy, right? Yes. Let's move on to something a little more challenging. Y equals e to the x plus 3, the quantity squared. Y equals e to the x plus 3, the quantity squared.
Teach me, Miss Bro. Teach me.
Okay. Do we need a rule here? We do need chain rules. We have a function inside of another function. The outer function is what? The squared, parentheses squared. The inner function is e to the x plus 3. So y prime equals, take the derivative of the outer, so what would that be? 2 parentheses to the first, and what goes in the parentheses? E to the x plus 3. And then you take the derivative of e to the x plus 3. It's just e to the x, because the derivative of the 3 is 0. Are y'all with me? Okay. Bring the e to the x and the 2 together. Y prime equals 2e to the x times e to the x plus 3, and that's done. Mm-hmm.
E means like number 2 in Korean. It's like you
Oh, it
write
does?
2 every time you say E.
Oh, okay. Interesting. Did not know that. Y equals 4e to the power of 1 minus 2x. Y equals 4e to the power of 1 minus 2x. The 4 is a constant that is multiplied to a function, and constants can just sit there. So when we copy and paste, we're actually copying and pasting the 4 as well. 4e to the 1 minus 2x times what? Negative 2. So y prime would equal negative 8e to the 1 minus 2x. And that's the answer to that one. See, these don't take very long. Are we good? Next problem. Y equals 2e to the square root of x power. You see functions in calculus like you've never seen before, right? We're mixing so many things together in one problem. I know. Okay, does the 2 get to sit there? Yes, it does. So y prime equals 2e to the square root of x times, be careful, 1/2 x to the negative 1/2. Exactly. Does everybody see how I got that? Okay, you're taking the derivative of this entire thing, which is x to the 1/2. So you got to bring down the power and lower the power and all that stuff. Okay, you will be tempted at times to try to bring this power to the front. You don't do it if it's got an x in it. If it's got an x in it, it stays there. And we'll talk more about that tomorrow. Okay, now I need to clean this up. Can I cancel the 2 and the 1/2? What do you think? Yes, I can. Those are free to cancel. And this x, having a negative, can go where? On the bottom. So y prime equals the e to the square root of x stays on top over the square root of x on the bottom.
Can you put e to square root of x times 1 over square root of x?
Yes.
If you want it like this.
I'll take it either way.
Okay. Because I got the other one.
E to the square root of x times 1 over the square root of x is sufficient as well. That's what Alex's question was. I'll take either way. Okay, your turn to try another one. Y equals x e to the x. Y equals x e to the x. Does this need a rule? Yes, it does. It needs the product rule. So listen carefully. I want you to do the product rule to this problem, and then at the end, I want you to factor out a greatest common factor. Okay? So do the product rule, and then factor out a greatest common factor. 1d2 plus 2d1. A lot of you are changing it to times. It's not. It's plus. Oh, that's a good problem. Okay. Y prime equals x e to the x plus e to the x times 1. Y prime equals e to the x times x plus 1. Nicely done by the majority of you. Okay, moving on to the next page. Let's do a couple more of these. Everybody done with that one? Example. y equals sine of e to the x. Y equals sine of e to the x. Okay, let me tell you how to tell the difference. You're not the only one who's probably thinking that. Sometimes it's not as easy to tell whether it's product rule or chain rule, okay? It is a guaranteed chain rule if there is only one x. Did you hear what I just said? It's a guaranteed chain rule if there's only one x. If there's two x's, you've got to do product rule, almost always, okay? So what is the outer function here? Sine, parentheses, and the inner function is e to the x. So what is the derivative of sine of something? Cosine of something, which in this case is e to the x, times the derivative of the inner, which is e to the x. This brings up an interesting question. Can you multiply those e to the x's together? No, because this one's inside of the cosine, this one is outside the cosine. That's the argument, that's not. But for a second, let's talk about if you could. Let's pretend like the cosine's gone. If you multiply those together, would it be e to the x squared or e to the 2x? That's a hard one to think about. Okay, when you multiply two terms, what do you do to the exponents? You add them. What's x plus x? 2x. So if you multiplied them, it would be 2x. But we can't. So just for future reference, because you may need that in your homework, e to the x, cosine, e to the x. We like to move it to the front to show that they don't combine. All right? Two more problems and we're done. Y equals e to the 4x over x. Which rule? Quotient rule. This is quotient rule. Y prime equals, draw your big fraction bar. So, low x. D high. The derivative of e to the 4x is e to the 4x, copy paste, times 4. What sign comes next? Minus, low d high, minus high d low. So high is e to the 4x, times d low is 1 over low squared, x squared.
Why didn't you put that x out?
That was the low.
Yeah, but
Low d high. You see it? Okay. Y prime equals. Now, all of this can just be put together. 4x e to the 4x minus e to the 4x over x squared. Now, just like on the problem you did by yourself, I want the greatest common factor out of there. So y prime equals, what can I pull out? E to the 4x, parentheses, 4x minus 1 over x squared. And that's the answer. Today is a rather easy day. I like this day. Okay, I have one more problem to do. Any questions up to this point before I do the last one that's a little more involved? Of course. Find dy dx by implicit differentiation. Dot dot. Give you a second to catch up with me. Find dy dx by implicit differentiation. This is going to take about 8 lines of paper. So if you're getting down to the bottom, you may want to change to a new page. Implicit differentiation. That is when, well, wait till you see the problem. A lot of times when you see the problem, you're like, oh, I know what to do with that. Here we go. X e to the y plus 8x minus 3y equals 0. Okay. Okay. This is just like related rates. Every time you come across a letter that is not an X, in this case, related rates, it's T, you always put A, D, whatever, D, X afterwards. Just like the related rates problems. Okay? Right here. Do I need a rule? I need product rule this time because I have two variables, an X and a Y. So they have to be done separately. So we're going to do product rule. So 1, which is X, times D2. What's the derivative of e to the Y? E to the Y, copy paste, times dy dx. Did everybody follow that e to the y dy dx? Okay, remember that the derivative of e to any power is just copy and paste that power, that whole problem, but then you got to take the derivative of the y. How do we take the derivative of y? Dy dx. Every time we come across a y, we write dy dx. Plus, that's 1d2. Now 2 is e to the y times d1. What's d1? 1. So we did the first term. Now the rest of them were simple. What's the derivative of 8x? 8 minus, what's the derivative of 3y? Just 3 dy dx. Derivative of 0 is 0. Remember the trick I taught you when you do these. Count the y's in the original problem, count the dy dx's on the next step. They both should be the same. I'm here, and 2 dy dx is right here, so I'm good. Okay, so I'm going to clean it up a little bit, and then we're going to start moving stuff. X e to the y dy dx plus e to the y plus 8 minus 3 dy dx equals 0. Get rid of all those parentheses and stuff. What do I do now? Move these two over because they do not have dy dx's on them. So x e to the y dy dx stays, minus 3 dy dx, that stays also, equals negative e to the y minus 8 take out the dy dx's next. Dy dx parentheses x e to the y minus 3 equals negative e to the y minus 8. And then you divide off the parentheses. So dy dx equals negative e to the y minus 8 over x e to the y minus 3. Thought I was going to make it through the whole page without making a mistake.
Do you factor out the negative 1?
You can. You don't have to. If that looks better to you to factor out the negative 1 on the top, then go right ahead and do it. And you're not the first person today to ask me that. Are there any questions about what I did? Okay.